Now, after when you come up with the lithium ion batteries, when you select, you have six type of different chemistries to work on. The first is lithium cobalt oxide, lithium manganese oxide, lithium iron phosphate, lithium nickel manganese cobalt oxide, lithium nickel cobalt aluminum oxide, and lithium titanate oxide. Okay. Now, this is what we call as a spider graph, which shows the parameters which are used, and this will tell you about which chemistry is good for which purpose. Okay, so let's start. So this LCO, what we call is as lithium cobalt oxide. Okay, so what it shows is that it has a high amount of specific energy as compared to, but low amount of specific power. Safety is also moderate, performance is moderate, lifespan is moderate, but it gives a cost. It means that cost as in good term, like is it economic in that terms, so good amount of cost. So the LCO are usually used in the, I guess, in the our battery cells in the laptop phones, so they have high amount of specific energy because they're lightweight, and the cost is clear, but lifespan is very short because you all know how fastly the cell phone battery dies out. Okay, and then what we have is LMO, lithium manganese oxide. Okay, so same, we go with specific energy is moderate, not as compared to LCO. Specific power is good, safety is also good than the LCO. Performance is relatively low, and then lifespan of the battery. Now the LMO batteries which we use, LMO batteries are more used in such vehicles like the Chevrolet Bolt and the Audi and the BMW i3. So what happens that manufacturers use LMO because of it, for you want instant acceleration, then MO provides good amount of current to be given because of its high specific power over here. So with combination of LMO we get a good amount of acceleration, and NMC's batteries are used in electric vehicles for giving high amount of range. As you can see, there's a good amount of specific energy, performance, lifespan with safety and all, and specific power and cost. So all these six parameters are maintained. So they are very optimum for developing electric vehicle battery. So NMCs are usually used in developing a electric vehicle battery because we could find a good amount of specific energy, specific power, safety is more than moderate, performance, lifespan, and then the cost is relatively good. Now we'll come to lithium iron phosphate. Specific energy is less, but we get high amount of specific power. Safety is very considered over here, and lifespan. So if you want to design a battery with good amount of safety and lifespan with specific power, then LFP is the chemistry you use. Then we have NCA. Okay, NCA is a little bit expensive. It has high amount of specific energy and specific power with performance, less safety, and lifespan is good. These generate high amount of specific energy with power. So these are usually used in the medical devices which we use, and then even Tesla using their powertrain. Now we have LTO, which is lithium titanate oxide. This is very expensive. It shows high amount of specific power. It has a good amount of safety. And the performance level are off the chart as compared to the other five with amount of lifespan. But the thing is, it is very expensive, and it is still not in use, in the practical use implemented because of its high expensive and low specific energy. So it will be used further, but LTO is not used in the electric industry as of now because of its high level of cost.